The researchers actually note that while other attention methods exist, like additive attention, which uses complex hidden layers and extra learned weights, this scaled dot product is vastly faster and much more memory efficient for modern hardware. It's a sleek aerodynamic calculation, highly efficient. Okay, so we have the math. We know how to score a query against a key to pull the right value. How did researchers originally integrate this beautiful attention mechanism into that old, flawed sequence to sequence model we talked about earlier, the one with the terrible bottleneck? This was the first major breakthrough. Instead of passing just one compressed context vector to the decoder, the attention mechanism was used to physically connect the decoder directly to every single output state of the encoder. It shatters the bottleneck entirely. It does. The straw is gone. The pipeline is blasted wide open. Exactly. In this setup, the outputs of the encoder's hidden states, the mathematical representations of every single French word in our sentence, become the keys and the values. Okay. They are the library signs and the books sitting on the shelves waiting to be accessed. And where does the query come from? The query comes from the decoder side. Specifically, it uses the output of the previous decoder state. Let's walk through a specific example for you listening to make this concrete. We are back to translating J'aime le thé to I love tea. Right. Let's imagine the translation is underway and the decoder just successfully generated the English word love. That word love and its underlying mathematical hidden state flows into the attention layer and acts as the query. It's the patron walking up to the librarian and saying, I just read the word love. What should I read next to finish this thought? Yes, the attention layer takes that query for love and calculates a scaled dot product score against every single key sitting in the French encoder. It scores j'aime, it scores la, it scores they. It evaluates the entire source sentence all at once. It doesn't rely on a compressed memory. It looks directly at the source material. And through that softmax function we discussed, the math figures out that based on the fact that we just generated the concept of love, the highest attention weight, the strongest geometrical alignment, should be placed squarely on the key for the French word fait. And because it focuses its mathematical attention heavily on the key for they, it pulls the corresponding value and the decoder spits out the English translation T. The bottleneck is dead. At any given time step, the decoder has the power to look back across the entire expanse of the source sentence and surgically pull exactly the specific context it needs, regardless of how long the sentence is. This is like a monumental victory. We completely fixed the information loss. The AI can finally remember the beginning of the sentence. It was a massive win.